Hello friends, welcome to lecture number 2 of Frobenius Method, how to solve differential equations using Frobenius Method. So we have already discussed first case of this method. So today we are going to discuss the second case. So we're going to solve this question using the Frobenius Method. So case 2, there are 4 conditions. Okay, there are 4 conditions. We have already discussed about one condition. So today we are going to discuss about another condition where if the roots of the indicial equation are same, that means m1 equal to m2, right? In that case our solution will be of this form. Solution of the equation will be of this form, right? So c1 y for m is equal to m1. Here m1 and m2 both same. If you write m1 m2, doesn't matter. Okay, so both equal to m, you can consider that way. Then c2 into partial derivative of y with respect to m, and m is equal to m2, right? That means we're going to put the value of m1 and m2. What are the roots we're going to have? Okay, we're going to put the put here in the expression of this 2. So here c1 and c2 are constants. Okay, now let's start. So here you see this is the given equation, right? So let us consider y is equal to this. Y is equal to ar x to the power m plus r. This is the solution. Summation from r is equal to 0 to infinity ar x to the power m plus r. So now let us obtain y dash, that means derivative of y, and that is given by ar m plus r, right? X to the power m plus r minus 1. Here we have applied this formula, ddx of x to the power n, you know, n into x to the power n minus 1. These are very simple things. I don't think I need to explain this. So similarly, again again differentiate it in order to obtain the second order y double this. So then you're gonna get this, right? So that's why that's what we have got. Now substitute those values, those expressions y dash and y double dash in the given equation. Let me take this one as equation number 1 and substituting those values, those expressions of y double dash and right. So I put it in here. That should be y double dash, single dash. Okay, y single dash y double dash in equation number 1. Let me take this one as equation number 2 as well. So now if we substitute those expressions, y is equal to this, y dash y double dash in equation number 1, in the first equation, right? Then we're gonna get this expression. Here you can see. So right, so instead of y double dash we have substitute this value, right, this expression, and similarly replace this y dash by this expression and y by this expression, right? So doing so we have got this result at the end, right? So this is the result we have got. Now you can take common, right? Just multiply x into this, first multiply x with this expression, then what you're gonna have, then this will be m plus r minus 1, right? On multiplication of x with this, right? So hope you have understood this. So now you see similarly we're gonna multiply this x, this x with this, then we're gonna get this result. So this is the result we have got. Okay, now let me copy this and let me go to the next slide. Okay, now let me copy this result, let me go to the next slide. So this is the result we have got in the previous slide. Okay, let me write this one again. So here is the result, that's what we have got. Now you see, find common terms. Here you can see these two are common. Okay, so taking those common things outside, right? So within bracket what we have got, we have m plus r minus 1 here, and from the second term we have got only 1, x to the m plus r minus 1 is taken common. Here you see, on taking these things common, here we have got only 1, right, from the second term. you can see clearly. Just wait. If you take these things common, you can consider this is into 1, so 1 is there, and on taking common this one and this part, we have got this part, right? So hope you have understood this. So this is the result we have got. Now this -1 plus 1 cancel, so if you multiply m plus r with m plus r, then you're gonna have m plus r whole square. So this is the result we have got, right? So now equating the coefficient of x to the power m minus 1 to 0. So how to equate that? Put r is equal to 0 in the first summation. So here you see equate to 0, right? Just wait. Here you can see in the first summation we have put r is equal to 0 here, right? And don't put here r equal to 0 because we have to keep this to equal. Actually the powers on x should be equal, but here you can see to make powers on x in these two terms, in order to make the powers on x equal, in first summation we have x to the power m plus r minus 1, in the second summation we have x to the power m plus r minus 1. As we are equating the coefficient of x to the power m minus 1, we have to put here r is equal to 0 in order to get m to the power minus 1, x to the power m minus 1. And sorry, here we had plus 1, right? In the second summation we have got this, right? So in order to get m minus 1 from this power, we have to put r is equal to minus 2, but r is a positive quantity, r is equal to 0. 0 is the lowest value, we cannot put r negative. So that is why we have put r is equal to 0 in the first summation only. And if you put r is equal to 0 here, then and also here and here, then what you will get? So this is the result you can have. So here you see a naught m square is equal to 0, and a naught cannot be 0, a naught cannot be 0. That is why, so m square must be equal to 0. So m1 and m2, the two roots are both equal to 0, because if m square is equal to 0, then m must be equal to 0, and as it is quadratic, there must be two roots, m1 and m2 both equal to 0 here in this case, and a naught is not equal to 0. So hope you have understood this now. So now what we're going to do, just here is the last result we have got, last expression that we had got, and equating the coefficient of x to the power m minus 1. We have in the previous slide, we have what we have done here equating the coefficient of x to the power m minus 1. Now what we need to do is just wait, just let me copy this part and let me go to the next slide. Okay, let me copy this part and let me go to the next slide. Just here you can see. So this is what we had got in the previous slide. So here you can see, as we have here what we have done, equating the coefficient of x to the power m minus 1. Now let's come to x to the power m, the next smallest power of m. Okay, so then what are we gonna have here, equating the coefficients of x to the power m so to 0. Now put r is equal to 1 in the first summation. Here let's put r. Just what we have done, we have put r is equal to 1 in the first summation only, but we cannot put to make it m plus to make it m, as we need to put in the second summation r is equal to minus 1, which is not possible because r is positive. So that's why we have put the r is equal to 1 in the first summation only, and doing so what we have got, so just wait, this is not required here, r is equal to 0 not required here, just wait. Okay, so what we have got here, so put r is equal to here 1. Okay, so putting here r is equal to 1, here also 1, and doing so what we have got this is equal to 0, right? So coefficient is being equated to 0, right? Equating the coefficients of x to the power m to 0. Yeah, so we have got this. So from here what you will get a1 is equal to 0. Now let us equating the coefficient of x to the power m plus r to 0, and in order to do this we need to put r is equal to r plus 1 in the first summation and r is equal to r minus 1 in the second summation, right? Then only these two will be equal, the powers on these two will be equal, right? So here you see powers on x to the power m plus r minus 1 and in the first summation, and in the second summation you have x to the power m plus r plus 1. So if you put r minus 1 here, then this minus plus cancel, then you will get m plus r, and if you put r plus 1 here, this minus 1 plus 1 cancel, then you will get m plus r, right? So hope you have understood this. So then doing so, what we have got this expression, right? So what we have done here, we have put r is equal to r plus 1 in the first summation and r is equal to r minus 1 in the second summation, right? And it implies this, right? Now you see one more thing. If a1 is equal to 0 and difference between these two, r plus 1 and r minus 1, in this term you can see r plus 1 and r minus 1. So just wait, I forgot the square here, there should be a square. Okay, so difference between r plus 1 and r minus 1, the difference is 2, right? The difference is 2. So in that case, if a1 is equal to 0, then all the coefficients for r is equal to odd number, a3, a5, a7, a9, those gonna be equal to 0. Okay, all the coefficients air for r is equal to odd, this is gonna be equal to 0. So we need to find the value of air for r is equal to even number. That means a2, a4, a6. Okay, now let me copy this term, steps, expressions, and let me go to the next slide. Okay, so what we have got at the end this, right? So now you see, let us put r is equal to 1 in order to get a2. Then we're gonna have a r minus 1 means 1 minus 1, that is a naught, divided by, if you put r is equal to 1 here, then you're gonna have m plus 2 whole square. And similarly putting r is equal to 3, because here you see, on putting r is equal to 2, you're gonna have here a 3 which is equal to 0, as I have already explained why it is 0. So that's why we are going to put r is equal to 3 in order to get a4. If you put r is equal to 3 here, then you're gonna get a4, right? So then this expressions becomes this, right? So now let us put the value of a2 here, a0, a2, yes, a2 is equal to minus a0 m plus 2 whole square. Let us put here. Then doing so, we have got this expression, right? Similarly we will get a6, a8, so on, right? Now from equation number 2 that we had taken, this y is equal to summation ar x to the power m plus r, if you expand it, then you're gonna get this, right? So on, so on, right? So now a0 x to the power m. Now if you put the value of a2, because here you see we have already got a1 equal to 0, a3 is equal to 0, Similarly, a5, a6, those are equal to 0. Now let us put a2, a4, a6, and doing so we have got this, right? We're gonna get this. Okay, so what we have done, we have put the value of a2, then after this we're gonna put the value of a4 x to the power m plus 4, then next term will be your a6 x to the power m plus 6, and doing so. So we have got, here we have, you see the pattern, m plus 2, here m plus 2, m plus 4, and here m plus 2, m plus 4, m plus 6, right? When the power of x is x to the power m, then we ended with x to the m plus 6, right? So here you see, that's how we can continue, right? This is the series. Now let me copy these things and let me go to the next slide. Here this one is y m, right? Let me go to, now you see, if you put m is equal to 0, as already we have got that m1 and m2 both equal to 0, so here y m is equal to 0, that will be equal to a naught x to the power 0 is 1. So then if you put here m is equal to 0, then what you will get, so you're gonna have this result, x to the power 2. So we can take a naught common, right? We can take a naught common, then plus x to the power 4, 2 square into 4 square, then minus x to the power 6, 2 square into 4 square into 6 square, and so on, right? So that is what we have got. This is our y m is equal to m1. That is what we have got, right? So now let me take this, let me copy this and let me go to the next slide. So here you see, so first again, if you take a naught common here from its term, a naught and x to the power m common, if you do that, then a naught x to the power m is taken common, then within bracket you're gonna have 1 minus x to the power 2 by m plus 2 whole square plus x to the power 4. So here this part is taken common, right? X to the power m is taken common, a naught is taken common, so m plus 2 whole square, m plus 4 whole square, then plus, sorry, not plus, next term is minus x to the power 6 m plus 2 whole square into m plus 4 whole square into m plus 6 whole square, and so on, right? So that is what we can have. So now you see, let's find del y del m, right, for m is equal to 0. That's what we're going to find. So first of all, just you can imagine this expression in this way, taking this considering these terms, this series within bracket, within curly bracket. Imagine this one as x to as z. Let me consider this one as z. So in that case, if you differentiate it, let me take this as ym. Okay, if you differentiate it with respect to m, both side, with respect to m, if you differentiate it, then what you can have. So let us apply, this is u, this is v, u into v rule, let us apply that. Then a naught z partial derivative of x to the power m with respect to m, right? Then plus you're gonna have a naught x to the power m partial derivative of z with respect to m. So here you can see that we are differentiating with respect to m, not x, right? Here we have x. So you must have got this dx of a to the power x. When you are differentiating with respect to x, a to the power x, then you had got this result, that a to the power x log of a. Now simply we have del m, so replace the x by m, and this a by x. So instead of a we have x now, so replace the a by x and x by m, and doing so your result should be something like this, right? And then a naught z x to the power m log of x, that is what you're gonna have from here. We're gonna deal with this part later. First let us deal with this. Okay, so hope you have understood how we have got. Now you can see a naught, this one is a naught. Here you can see this is x to the power m, this is also x to the power m, this is z, this part is z. That means you can replace this part as this, right? This is your ym, right? So you can replace this part by ym. So let me cut these things. So you will get here ym log of x. So now let us evaluate this, let us obtain this del z by del m. Now let us obtain this. Just let me do one thing, let me show you how to differentiate each term of this part. Here this z represents this part. Let me go to the next slide. This is nothing but your y m, right? So just wait. As you can see that we have considered this part is as z, right? If you find del z by del m, then this should be 0, and take x square as constant, then del m of you can say m plus 2 whole to the power minus 2, right? Similarly x to the power 4 del m of m plus 2 whole to the power minus 2 into m plus 4 whole to the power minus 2, and so on, right? Now you see del m of here you see. So first we have taken this m plus 2 whole to the power minus 2, that's going to be equal to minus 2 into m plus 2 whole to the power minus 3, right? If you differentiate it, you're gonna get that, right? Which also can this also can be written as minus 2 by m plus 2 whole cube, right? You can write that way. Similarly del m of m plus 2 whole to the power minus 2 m plus 3 whole to the power minus 2, sorry not 3, there was 4 to the power minus 2. That means I am differentiating this part. Here you see this term, derivative of this term. So 4 is taken as x to the power 4 is taken as constant. So here you know 1 by m plus 2 whole square can be written as m plus 2 to the power minus 2, right? Similarly here m plus 4 whole to the power minus 2. So if you differentiate that, so if you apply the product rule u into v, then you're gonna get minus 2 by m plus 2 whole cube into m plus 4 square, then similarly plus the first function, derivative of first function is this one into second function, then now first function derivative of second function, first function is now here m plus 2 whole square, then derivative of m plus 4 minus 2, m plus 4 to the power minus 2, that's going to be minus 2 into m plus 4 whole cube. That's what. So this is what we're going to have, right? So now you see from here you can take minus 2 m plus 2 into m plus 4. You can take this to common, right? M plus 2 whole square m plus 4 whole square. If you take this common, then what will be inside the bracket? 1 by m plus 2 plus 1 by m plus 4. Similarly, if you differentiate this term, then just wait. If you differentiate this term, then here you're gonna have just wait, minus x to the power 6 del m of m plus 2 whole to the power minus 2, m plus 4 whole to the power minus 4, m plus 4 whole to the power minus 2, then m plus 6 whole to the power minus 2. Right, if you differentiate this part, then what you're gonna have? Del m of m plus 2 whole to the power minus 2, then m plus 4 whole to the power minus 2, and m plus 6 whole to the power minus 2. If you differentiate, if you use the product rule, then here the common part will be minus 2, m plus 2 whole square, m plus 4 whole square, and m plus 6 whole square. Then within bracket you're gonna have 1 by m plus 2, 1 by m plus 4, and 1 by m plus 6. That's how you're gonna get this results. Okay, so hope you have understood this, and so on you can continue your differentiation. Okay, and putting those results here, you can see we can put those results here. Then we will obtain that ym, just wait, then we're gonna have del y by del m, that should be del y by del m, right? So at m, ym log of x plus a naught x to the power m. So what are the terms we have taken here? Okay, then you will get, just wait, here you can see we have minus x square, right? Then its derivative is minus 2 by m plus 2 whole cube, right? Then this minus, and here we have minus x square, so it's gonna be, if you multiply minus x square here, that's gonna be plus, right? So plus here x square, 2x square, that's what we're gonna have, right? So that's why within bracket we're gonna have twice x square by m plus 2 whole cube, right? And then next term we have a plus x to the power 4 plus x to the power 4. Here you can see we have here minus 2. If you multiply here plus x to the power 4, so we can write here x to the power 4 as well, x to the power 4. Okay, then next term should be minus 2 into x to the power 4 by m plus 2 into m plus 4, and within bracket we have 1 by m plus 2 plus 1 by m plus 4, and so on. Then next term, so let me go to a new slide. Let me take this and let me copy this, and let me go to the new slide. So here you see then the next term, here you can see just wait, here you can see we have minus 6x here. So if you multiply here minus 6 minus x to the power 6, so as we have minus x to the power 6, so if you multiply here minus x to the power 6, so this minus will be plus x to the power 6. So here we should get plus 2 x to the power 6 by m plus 2 into m plus 4 into m plus 6, and within bracket 1 by m plus 2 1 by m plus 4 plus 1 by m plus 6 and so on. Then right, so hope you have understood this square here. So I forgot to give the squares. Okay, just wait. So put it square here. Okay, so now we need del y by del m at m is equal to 0, as we have got both m1 and m2 is equal to 0, right? So if you put here m is equal to 0, here in all the terms replace the m by 0, then you're gonna have y m is equal to 0 log of x plus a naught. X to the power 0 means x to the power 0 means 1. So and if you put here m is equal to 0, then you should get 2x square by 2 cube, then which cancels this 2 cube to give 2 square, right? So here we're gonna have x square by 2 square, right? Then next time this minus this plus minus, then if you put here 0, then you're gonna have 2 square here. So again this 2x to the power 4, 2 square into 4 square, so this 2 squares cancels 2, right? 2 square to give 2. So here we're gonna have x to the power 4 into 2 into x to the power 2. Then if you put here 0, then we will get 1 by 2, and here we're gonna have, if you put 0 here, 1 by 4. Then you can take 1 by 2 common from these two, then this will be 2 square, this one gonna be 2 square, and this gonna be 1, and this gonna be 1 by 2 on taking 1 by 2 common, right? Sorry. So if you take 1 by 2 common, then there will be 1, then here it will be 2, 1 by 2, right? We had 1 by 2 plus 1 by 4, we have taken 1 by 2 common. So if you there was only 2, so x to the power 4, 2 into 4 square, right?